Hello, my name is Gary Rosa and I'm a student enrolled in the MATE course at the University of South Florida. Today I will be talking to you about my final project, an RC car damper dynamometer. This CAD model shows the system and how it works. A DC motor drives a crank slider mechanism which in turn pushes the damper up and down. The forces in both compression and tension are then recorded by a load cell. This is a more detailed view of the crank slider mechanism. It is driven by a DC motor and a piston which moves the damper up and down. The control system works the following way. A rotary potentiometer is used to select the speed setting at which the system is going to run. A push button is then pressed to alert the system that it must run. Once the push button is pressed, the DC motor starts running and the crank slider mechanism pushes the damper up and down. In the meanwhile, a load cell records all the forces in both compression and tension. An LCD displays the state of the system and the velocity setting. This is the control system in action. As you can see, the rotary potentiometer changes the speed setting. Once the push button is pressed, the system is running and the status is displayed by the LCD screen. Here the crank slider mechanism is shown in action. As you can see, speed setting 2 moves the system in a high velocity way. Speed setting 1, on the other hand, moves the system in a very slow fashion. Here's the full mechanism including the damper and the load cell. As you can see, the crank slider mechanism pushes the damper in an upwards and downwards manner. In the meanwhile, the load cell records the forces in both compression and tension. This can be done for multiple speeds. Once the force is recorded, it can be plotted in the force velocity curve. The slope of this force velocity curve is then extracted and used to determine the damping ratio of the damper. You can make adjustments to this damper and remeasure the damping ratio through the use of this damper dyno.